Okay, everybody listen up. This is an exponential. This is what we started with. So you would have said y equals ab to the x. How many of you knew to start with that? Okay, that's a good step. Next. Hope you guys are talking about math. This a is the starting value, and that's she's brushing for 5 minutes now because she's motivated. And the B is also something we can figure out because she's increasing by 5% per day. You put in 1 plus 0.05. And then you put it to the X. Now, if I had said how long, if I had told you I wanted the brushing sessions to be like 15 minutes long, you'd have put the 15 here. And then you would have graphed both sides and see where they cross. Okay, but I didn't do it that way. Just so you know, though, if you ever need to solve one where there's an X in the exponent, the only way you can do it is graph both sides and see where they cross. But what you guys were asked to do instead was, if it's 12 days later, you put the 12 right there, and now you figure out the final answer is, what's it, like 9 point something or something? 8.9. Okay, so I'm going to round it to about 9 minute brushing sessions. So she's brushing more and more each day so she can get her teeth back. Okay, anyway. I know they don't come back, but actually I was amazed at how many people in Hollywood, if you ever look at them and you're like, how do they have such perfect teeth? A lot of them, they're fake. Like literally. It's not just bleaching, I mean there's that, but a lot of them have porcelain teeth that go over the top of your normal teeth. Like you should see Tom Cruise's picture before and after. Holy crap. It's pretty amazing. So if you have nice white teeth, you're better off than a lot of the celebrities. They didn't, but then they paid it's like $12,000. You can have all new teeth put across the front, and your other teeth are still there, but they're behind, and this porcelain is glued on over the top, and of course they do a perfect job, so you can't see where it is. But anyway, so don't ever feel bad looking at the people that are overly beautiful or their teeth are overly perfect. It probably is fake. Okay. Okay, I'm hoping that didn't pick up on the recording. Here we go. To begin with, I'd like to, well, I guess we began with the other problem, but I'd like to give you another, I'm already recording. I'd like to give you a problem. This one is similar, except I'm going to give you a real world situation. I want you to write me the equation for it. All right. Actually, I can go the other way. I'm going to give you the equation, and you give me the real-world situation for it. If this is about gerbils, I want to know two things. I want to know how many were there to start with, and I want to know what is the maximum sustainable population of gerbils. Don't say it out loud. Okay, I thought you were going to give an answer. I want the start value. And I also want what's the maximum sustainable population. And don't make yourself feel really good if you know the second part. The second part is incredibly easy. The first part's the hard part. What is the starting value? And it's not 15 and it's not 1. It's not going to be quite that simple. All right. The maximum population part, super easy. What is it? 15. Because if you know where to look on these, the limit to the growth is 15. Should, theoretically, there ever be 15 gerbils? Theoretically. No, it approaches 15, though. So in other words, 15 is kind of their max, and theoretically, it should never approach 15. Okay. And why would you ever have a maximum population like that? Well, maybe there's a very confined amount of space. Maybe they're only being fed so much per day. Like they put out a dish of food every day, and that amount of food is only enough to feed 15 of them. If there gets to be 20, some are going to starve to death. And then the population goes down again. Anyway, the point is you can limit populations. That's why they get limited. Otherwise, theoretically, we'd all be overrun with mice and rabbits because they multiply so rapidly. But thankfully, they're like the happy meals of the great outdoors, so they just get eaten all the time. All right. Start value. Start value is a little tougher. The start Start value is where you start, which is at time what? 0. That's the key. If it's time 0, that's a 0. What's e to the anything? Oh, no, sorry. E to the 0 is 1. So 1 plus the 1 means on the bottom there's a 2, so it's 15 over 2. 15 divided by 2 is 7.5. How is there half of a gerbil? I don't know, but that's the way it is. Okay. Now let's talk about some new stuff for today. I'm going to give you one and see if you can handle it. If I give you this, y equals 3.5 times 1.09 to the t, I'd like you to tell me things you know about this. Just tell me. Raise your hand. Tell me something you know about it. Yes? 9% increase. Another word for that starts with G. Growth. Okay. So this is a growth problem. Is it exponential? Okay, because there's an x in the exponent. In this case, it's a t, but all right. What else do you know about it? Starting. Starts at what? 3.5. Okay. And how about if I change the problem to have an x down here, a t down here? Is this still exponential? No, can't do that. Can't have, just because there's an exponent that's up here, there can't be the same letter down in here. That's not okay. All right, let's move on. One of the problems from last night was kind of like this. It was a population problem, and I think a lot of people may have had trouble with it, and I want to just see if you can get one right now. Okay, let's say in the year 2000, I'll keep it really simple. In the year 2000, there were 400 people in this town, and in the year 2007, it was up to 498 people in that town. My question for you is, pause just a second here. Come on. Okay, sorry about that. I want you to take this data and I want you to write me an exponential equation for it. And I want you to use that exponential equation to figure out when will the population, if it continues to grow the same way, when will the population hit 600? Notice, I'm not even going to put that 600 on the board yet because you don't need it for a while. A lot of people want to stick that into the equation right away. That's wrong. That doesn't work. I'm seeing iPads used in two different ways in this class. I'm seeing them used for good, and I'm seeing them being used for evil. I'm not going to say who's who, but make sure you're the one that's using it the right way. Otherwise, you do not have the right to use it all the time. Just because some people can't control themselves doesn't mean we shouldn't have guns, necessarily. Well, some people will argue that. How about cars? How about cars? You can kill people with cars. Nobody be able to drive them? Well, anyway. Okay. All right. If I do what I just did and put in 400 for the start value, what do I immediately need to do? Okay. Now, shh, quiet please. All right. So I have two options on this. If I'm going to make my start value be 400, then I need to change that to be a starting value year. What should it be then? 0. And if I change that to a 0, what do I change that to? A 7. Okay, there's another way to do it, but if you're going to say 400 goes right here, then you have to change your year to be a 0, and then therefore your other year would have to be a 7. Okay, then your x and your y. This is your x. This is your y. 7 goes in here. 498 goes in here. Then you solve for b. Go ahead, do that quickly. I want everybody to do it. Divide by 400. And this is 1 point what? 245. Okay, and then I put it to the 7th power, or sorry, to the 1/7 power to fix this. And then b is equal to, is it 1.03? All right. So then I've just figured out b. Now I can rewrite the equation. Y equals 400 for a start times 1.03 to the x. Focus, please. All right. That's my equation. Do you notice I never even used the other number that I told you? Like I said, when did the town get to 600? Do I ever even used that? Okay. That's the point. Don't use that number until the very end. Once you've got your equation done, now I can use the 600. Where should it go, y or x? X is time, and 600 is not a time. So 600 wouldn't make any sense up there, right? Okay, so that's why we put it here. And now, how do you solve that? You have to graph both sides and see where they cross. Unless any of you are masters at logarithms already, which I don't think you are, you may have learned them last year, and if you can do it with logs, awesome. Most of you aren't going to be able to. In which case, you should graph both sides and see where they cross. I'll show you later how to do logs. What?
No, to find the x.
You're trying to find x, yes. So you graph both sides. Y equals 600 and y equals that. Everybody get that up on your calculator right now. I want to make sure you know how to do that. This is not like, that's neat. If you want to get a good score on your next test, you got to be able to do this. I will swing by and take a look at your calculators in a second. If you're having trouble with it, ask. First of all, get it into graphing mode. You don't want it in sequence mode. So make sure it's in the right mode. Then go to your y equals screen and start typing. The two equations you're looking to type in, these guys. That and that. You don't want it in sequence mode. Use the only other logical mode, which is function mode. Okay, I have determined that almost everybody is doing this right now. So, once you do second calculate intersect, what do you think is the important thing, the x or the y? What's the one thing we didn't know? X. So the x is what we care about. What is the x of that intersection point? 13 point what? 7. Good enough. Okay. Shh, quiet please. I can't hear because there's like 17 people talking. 13.7 or 13.8, whatever you want to round it to. What is that? Is that like the number of gerbils in Germany, or what is it? It's the number of years. So if they asked you for the number of years and you wrote 13.7, wouldn't it have been a lot smarter to say 2000 what? 2013 wouldn't be quite enough, right? 2014. Get what I just did there? This, you have to figure out what it is. It's a number of years, and the years were like this, and the years we changed. So, all right. One last thought on that one. I want to go back and say, how could we have done this a different way? We could have got the starting value differently. Let me show you. Listen, because this is really important for the next kind of problem. All right, if you want to take these numbers and put them into your equation, you could. You could just put them in directly. 2,000 and 400. Year is 2,000. That's an x, isn't it? Isn't that an x and that a y? So couldn't I put in the 2,000 in for x and the 400 in for y? Okay? If I did that, I'd need to still know what the a was. Okay, so if I put in a 400 right here, then if I'd have an equation I could solve. I could divide by 400 on both sides. I'd have 1 equals b to the 2,000. Okay, it would be a lot easier to just get your starting value the way I showed you, which was, say this is the starting value, but then this has to be a 0. Okay, that's my preferred way of doing it. And then you got to remember to change this one to subtract the 2 and say how much further was 7 years along, so 0 plus 7 is 7. All right, that's a critical kind of problem. Here's another. I'm going to give you a situation, and I just want you to tell me, write me a function for this. If I start with 70, and I'm going to go up 12% a year. Write me an exponential for it. Okay. 70 going up by. Good. I was going to say, so what should it be? All right. Now is it right? Okay. I wanted to make all mistake in it. I seriously did. I was going to say, okay, so what's wrong with that one? All right. Now, if I did this, do you know what I'm getting at? What kind of problem do you do that with? Okay, you guys, you got to stop talking. Okay, I'm asking for answers. I'm talking about the talking that wasn't about the answers. Okay, so what? That's about half-life questions. Do you remember that? All right, now I'm going to give you a half-life question. So let's say something has a half-life of 23 days. Tell me an equation for. Now, if you think about this, doesn't it mean half-life? Doesn't it mean that you're losing or decaying by 0.5? Okay, so you can do it that way if you want. I want a half-life situation where you've got 50 grams of the stuff, and its half-life is 23 days. Started with 50, right? Half-life's 23 days. What's wrong with what I said? Yeah, there's no x in it. This is not an exponential. X over 23 would be right, though. Okay, 1 minus 0.5 is the same exact thing as 0.5. And this is half-life. This is decay. That's what half-life is about. So this is written right. It's not supposed to be plus. But you could change that whole thing to just a 1/2. Because 1/2 minus, or 1 minus a half is a half. All right, so some people do their half-life questions where they put a 1/2 right there. And I totally understand that. But do you get why I write it as 1 minus a half? Shows that it's 50% decay. All right. Okay, now let's go into, if I give you a bunch of data and all you have to do, just puzzling over this because this worksheet is really pretty easy for today. I guess I won't just torture myself with making you try to learn the really weird situations. I think your worksheet's going to just be fairly easy for you. One problem that I want to go over one last time is this kind. Say I give you a start of 0, 5, and I give you another point of, let's say, 10, 10. Can you write for me what the equation for that would be? This should be an easy kind. When you're done, it should be something like this. Y equals 5 times 0.6 to the x. I'm trying to write me an equation for this. That's not the actual answer. The beginning was right. Five does go in there, so that's the start value. Now you got to put in the other point. 10, 10. Figure out the b. 10 equals 5 times b to the 10th. Then you divide by 5. 2 equals b to the 10th. Then you put everything to the 1/10 power. So what is 2 to the 1/10 power? 1 point what? 472. Anybody else agree with that? Okay, good. Then final answer is y equals 5 times 1.072 to the x. Now, you're only going to do that half-life thing where you like to say in 8 days, only if it's a half-life question, okay? Because I didn't ever tell you how long it takes for this thing to go up by 7.2%. If we don't tell you, you can assume it's per year, and therefore you can just write them like this. And if it's the daily thing, in 8 days, it would be something like that. All right, I think that's all you need to know for today. It should be a pretty easy one. Here is your homework. If you need help, come on up and ask.